Hey techies, welcome back to another video. Today we will be go deep onto the Java loops. It's just a not 10 minutes surface stuff. We'll be spending our hours to make loops so convenient for us to use. And the loops are the heart of the programming language because we'll be using in every program that we will be solving in the higher orders. Like DSA, we'll be maximally using loops. So there are three loops are there: for loop, while loop, and do while loop. Mostly we will use for loops and while loops, and sometimes we will be use do while loop. Okay, in the for loops we'll be seeing the syntax variations and prime numbers, factorials, palindromes, and for the while loops we'll be guessing games and password retries and series calculation. And the do while loops we'll be seeing menu systems and input validation through the rules at least. So you may ask the questions that why we need three loops. There are different scenario of cases that we will be using three different types of loops. So, and as well we will be seeing break and continues. In the previous videos of conditional statements we have seen about the break, and we also use like that the same thing, but we will be using one more thing called continue. So we will be see why we will be using these two, and after that some of the practice challenges you will be coding with me, then some debugging, that escaping the infinite loops, and fix off the one of the errors, and what are the most people do in the errors. So you code along with me and pause when you need it. Let's build up the loops. So starting now, first we will be see what is a loop. For example, imagine if a factory conveyor belt, same action repeats, like if it grabs the box and stamp the label and move forward. We will see the syntax for the for loop will be like that. So we will be seeing after that. First we will see the loop. So for example, in a factory there will be a conveyor belt like this. There will be some rollers, and here the boxes will be put up on that, and it will move here, and after that some stamps will be put on them and some sealing will be put on them. Then after that some more boxes will become. This will be doing infinitely. This loops will be run until the boxes will be packed. So same like that, a loop repeats a block of code while the condition stays true. So the why loops matters is because without loops, for example, printing 1 to 100 needs 100 println lines. But with loops, we only need 3 lines. For example, in Java gives us the 3 main types. For loop, when you know how many times the loop repeat, you will be using the for loop. 3 types of loops are for, while, and do while. When we use for loops, when you know how many times the loop will run. When we use while loop, when you repeat until a condition changes. For example, when it becomes the condition become changed, for example true to false, it will give false, and the loop will be terminated. That means if a condition changes, then there is some changes will be happened there, so then it will be terminated. So we will be seeing about do while. For is when you know how many times the loop will run. While is when you don't know how many times the loop will run. Do while is same as the while, but the do while will at least run once. In this video we will be mastering all 3 of them. So we will be starting with the for. So first we will see the syntax for the for loop. Watch closely. The for loop has mainly 3 parts inside the parentheses. Let me break down it. First I will write that parts are for, then initialization, after that condition, after that updation. These are the 3 main elements in the for loop. After that the curly braces, within that the code that has to be repeated. Okay, this is the main syntax: for, initialization, condition, updation, and the code that have to be repeated. Okay, first we will see the first part, initialization. Okay, initialization. So this runs once before the loop starts. See here, this will only execute only once. This initialization part is only once in the loop. Okay, for example, mostly we will be using like int I equals 0. The I will be refers to iteration, so most of them is I. Then the second part, that is condition. Okay, this will be checked before each iteration. If returns true, then the loop will be runs. If false, the loop will be exits out of the loop. The next line, the compiler will go to the next line. So then, for example, if I is greater than 10, that means when the I value will be greater than 10 or 10, it will become false, then it will break out of the loop. This is mainly needed to make the loop runs, and it is the main condition that is needed to stop the loop. So then we will be move on to the third part, that is called updation. I'll write it as update. Then see here, after each iteration we have to update the value. For example, I'll make this 0 to 1, then 1 to 2. If I don't change this initialized value, then what will happen? It will become an infinite loop, because always 0 is less than 10. I have written greater than here. I have changed it to less than. Okay. If for example 0 is less than 10, that means it's true. If we don't change the value, it will still become 0. So now what will happen? It will run infinitely. It doesn't know when to stop. So if we update to 1, then 2, then 3, like that, when it reaches 10th time, 10 less than 10 will return false. In that time the loop will be break. We can do I plus plus or I minus. In the operators class we have mentioned what these things. If you don't know what is these things, I plus plus and I minus minus, make sure to watch that video and come after that and see this video, so you don't get any doubts regarding that. So all three parts are optional. For example, if I write for and a colon and a colon, and it creates an infinite loop. So we will be demo that in the later. So let's see it live. For example, I'm opening it. I have write the code for, it's now shows an error because I didn't give any values. But if I give this, see here, it says empty statement after for, but it doesn't show any red color lines. That means it's not showing any errors. If I remove any single one of them, it shows a red error. So empty statement after for and illegal start of the expression. So that's why you have to give like this. Okay, if I run this, the loop will be terminated because we have to give curly braces here. If I use semicolon there, it will run only once. So I have to give a curly braces. Now if I run, we will see an infinite loop. That means it's going on, going on, going on. For example, I am printing something within this. So first I stop this loop. After that, I am printing hello. So if I run this, see here, it goes on like that. We have multiple hellos, right? So we can give this, but we'll get into an infinite loop that won't stop. When the compiler is not able to store this value, that means the stack overflow, then only the loop will be terminated. So until then this will be printed infinitely. So I have stopped it manually. So we will be seeing the printing statement from how to print 1 to 100. So first we will be seeing the whiteboard. So the syntax is first for keyword, after the for. The initialization part is nothing but where we will be starting. So I am starting from 1. So that means int I equals 1. I have initialized. Next, I have to stop the loop when it has to stop. That means I have to give a condition. When that meets that condition, it will be failed. After that, it doesn't have to print. That means if my I is less than or equals 100, that means it can print up to 100. After that, I have to increment once per loop. First the I will be 1, then if I increment it will be 2, then if I increment it will be 3, then 4, up to 100. When it reaches 101, the loop will fail and it will out of the loop. Then if I print I, then I will get 1, 2, 3 like that up to 100. So let me check in the compiler and I will trace it how it works. For that, we have to first initialize within the for loop. Starts from 1, then I less than or equals 100. After that, I plus plus. Okay. Now see here, I have to print the I. So I just printing I. If I run this code, I will be getting the outputs from 1 to 100. See, when it reaches 100, it fails. So we will see the iteration in the whiteboard how it's working internally. So first what will happen, I'll write the condition. For example, let me take 1 to 5. Okay, I'm writing a loop for int I equals 1, I less than or equals 5 and I plus plus. So then curly braces, and we have to print I. So we will see the iteration here. So now first what will happen, the value of I is 1, then it will check 1 less than or equals 5. It is true, then it will go into this loop after checking the condition, then it will print the I. The current value of I is, so I am writing output region and it is 1. Then after executing, it will go here, the updation part, then it will increment the value I equals I plus 1, and that means I equals 2 now. So the current value of I will become 2, then 2 less than or equals 5, it will return true, then it will print this within the code block, then we will get 2 in the output console. After that increment, then I will become 3, then the current value of I will become 3, then 3 less than or equals 5, that means it is true. So after that we will be printing the 3 in the output console. After that I will become 4, then the I is equals 4, 4 less than or equals 5, it will return true, then 4 will be printed in the output console. After that I will become 5, then I equals 5, 5 less than or equals 5. Here if it's 5 less than 5, it is false, but for 5 equals 5, it is true, so it will return true. So it will return true. Then here we will be printing 5 in the output console, then the I will become 6, I value will become 6, then 6 less than or equals 6, 6 less than or equals 5, then that means it will return false. So the loop will be terminated, then it will come out of the loop and execute to the next loop. Okay, that's how when it reaches 100, it will print it, because 100 is less than or equals 100, it is true. Then it will change to 101, 101 less than or equal to 100 will return false, and it will not execute this printing line. Is that clear? See here, as I said before, this initialization code will be run only once in a loop, and this condition will check for the every iteration. Then after every iteration the block of code executes, then only this updation part will be worked. Okay, then we will be printing it from reverse. For example, we have printed from 1 to 100. Now we will be printing from 100 to 1. First we will write the iteration. After that we will see in the Visual Studio Code. So for that, as I said before, we have to write in the reverse direction. Correct? So first, for, as I said before, initialization is the starting point. So where do we have to start? For example, we have started from 1 to 100. Now if it reverse, that means we have to start from 100, right? So I initialize the value of I to 100, because we have to start from the 100. Then I have to stop when it reaches 1. That means if I is greater than 0. Okay, because 1 is greater than 0, 2 is greater than 0, 3 is greater than 0, but 0 is not greater than 0. So that's why I am using I greater than 0. Then what we have to do, we have to decrement the value in the curly braces. Within that, the code that have to be repeated. I am again printing the value of I. So it will return 100 to 1. Okay, now let me see for the example of 5 to 1. Int I equals 5, I greater than 0, and I plus plus. Oops. I minus minus. So now we will print system.out.println the value of I. Okay, we will see the iteration here. Now let me check. First, the value of I is 5, then 5 is greater than 0, it returns true. Then the code will be executed in the output console. It will print the current value of I equals 5. After that the value will be decremented by 1, I will become 4, the current value of I will become 4, then 4 is greater than 0 will return true, then it will print in the output console. After that I value will become 3, then 3 is greater than 0, true, then it will print 3, then I will become 2, after that 2 greater than 0, true, then it will print 2, I will become 1, and I equals 1, 1 greater than 0 will return true. After that it will print 1, next it will go to the updation part and I will become 0, here I will become 0, 0 greater than 0 will return false, because both are equal, so it will return false. Then it will terminate the entire loop, then go to the next line. That's how it will print 5, 4, 3, 2, 1. For example, we'll run from 100 to 1. So let me see in the Visual Studio Code. For that, I will initialize the value with 10. After that, I is greater than 0, I minus minus. Right. So now what will happen? It will print from 10 to 1. See, have got from 10 to 1. We have counting in the reverse order. As I said before, this initialization runs only once. After that, this will check in the every condition of loops. Then the updation will done after the printing of this statement. That means the repeated code executed, then only the updation part will be done. This is the same structure, but we have just flipped the initialization to 10. Then the condition to greater than or equals 1 or greater than 0. So we will be updated by I minus minus instead of I plus plus. Okay. This is the essential for the timers. For example, in the timers it will count from 10 to 0 like that. So this is how that works. Then the reverse sequence we will be using this. Okay. If you have any doubts, but first just ask yourself that what is the starting point and what is the ending point. Then the step size. So if you find the answer for those, then you will be easy to design your own loop. For example, this is the starting point and this is the ending point and this is the step size. Step size is nothing but how many steps we will be decreasing. For example, if I give I equals I minus 2, then if I run it again, see here, we got 2 steps jump, 10 to 8. We have skipped the 9. For example, if I give I equals I minus 3, we got 3 steps. 10, I have jumped to 7. After that, we have jumped to 4, then to 1. So maximally we will be using single steps, but for the different cases, we will be using this. Okay, then we will be seeing some problems with the custom step size. That is nothing but the different step size that we want for our own. For example, if I want only odd numbers, in the condition we have know how to print odd and even numbers. That means if a number is divided by 2 and return the output as 0, that means the remainder is 0, then it is nothing but a even number. If it returns 1 instead of 0, that means it is a odd number. Okay, so first we will see how this works. For example, if a number is divided by 2 and give the remainder as 0, then it is a even number. If it returns 1, it's odd. For that, if we see a number line, without using this condition, we can print odd numbers. How? Because, for example, let's start from 1 and 2 and 3 and 4, 5, 6, 7, 8 and 9. This pattern, see, after every 2 numbers, for example, after one number with a step, we'll get odd numbers. See here, 1, and if we skip 2, we'll get another odd number 3, and we skip 4, we will get another odd number 5. If we skip 6, we'll get another odd number 7. If we skip 8, we'll get another odd number 9. Same goes for even numbers. If I skip 1, I got 2. If I skip 3, I will get 4. If I skip 5, I will get 6. If I skip 7, I will get 8. Like that it will go to the n number of times. So we'll be see how to print odd numbers first. So for that, I'll be using a for loop. As I said before, in the loops, you have to ask 3 questions yourself. Where to start, where to end, how many steps? These are the questions. First, where to start. That means initialization part. In this, it will start from 1. Because the odd number starts from 1. So we get the starting point. Then where to end. So for example, I just want just up to 10. So if I is less than 10 or else less than or equals, but I just using I less than 10. Because 10 is even number, so it won't be counted. So I am just using I less than 10. After that, here is the important point. As we have seen in the number system graph, 1, 2, 3, 4. If we go one step, we will get even number. If we go 2 steps, then that means we will get the same type. That is nothing but the if it starts from even, we'll get even. If you starts from odd, you will get odd. So that's why we will be stepping I plus equals. That means 2 times. Then we will be printing the I. So if I print this, let's check the iterations. First I will become 1, then I check 1 less than 10, it will become true, and it will go into the loop and print the value as 1. Okay, then the I value incremented by 2, then 1 plus 2 will become 3, then 3 less than 10 will return true, then the 3 will be printed. Now the value will be incremented by 2, then 3 plus 2 will return 5, 5 less than 10 true, then we will be printing 5. Then we will have to increment, I will become 5 plus 2 7, 7 less than 10 will return true, then 7 will be printed. The value of I will be incremented by 2, 7 plus 2 will return 9. So 9 less than 10, it will return true, so we will print 9. After that we have to increment the value, I will become 11. So 11 less than 10 will return false, it will get out of the loop, then we will get the output as these 5 numbers, 1, 3, 5, 7, 9. So we will check in the Visual Studio Code. Let me check. So first we have to ask ourselves where to start. I am starting from 1 because odd number starts from 1, then I less than 10, then I plus equals. Then what I have to do? I have to print I. So if we print this, we will get odd numbers. For example, if I give 100 here, I get all the odd numbers up to 100. Same goes for even numbers. So where will be the even number starts from? It starts from 2. So I am just taking it as less than or equals 10 because 10 is also an even number. So I am using less than or equals. So I am just stepping 2 times. Why? Because if we see here, it starts from 2. The same goes for even numbers also. If I skip one number in between the even numbers, we will get the even numbers. So that's why I will be using I plus equals 2, then I am printing. Now we will get even number. For the even numbers and the odd numbers, we just have to skip the steps by 2 times. Okay, now what we don't have to do in the loops. Okay, for example, the loops can lead to infinite loops. For example, first I have said before, if I didn't give any conditions and just give for and a semicolons, and now what I got is an infinite loop printing until the stack will get overflowed. So the condition what we don't have to give. For example, let I write a code. So you just try to find the bug in it. So I write a code for in I equals 1. Then if I is greater than 0, I plus plus, then I will be printing till running. Like that. Okay. Now try to find the bug here. So let me check here. First we will be tracing. First I will become 1. Then check 1 greater than 0. Then it is true. Then it will print still running. After that the I value will be incremented to 2. 2 greater than 0. True. Still running will be printed again. Then I will become 3 and 3 greater than 0. And it will become true, then it will still running. See here, this will run infinitely. Why? Because after that the every number is incrementing instead of decrementing. That means it will go like 4, 5, 6, 7. All these numbers after that will be greater than 0. So it will run infinite time. Okay. So this condition is important alongside with the updation part. These both have to cooperate with each other. For example, if I give I greater than 0, I have to do I minus minus according to the initialization part. If I initialize with 100, then I have to do this. If I initialize it with 0, then if I give I greater than 0, it won't run even a single time because 0 is greater than 0 will return false. Okay. For example, if I give I less than 10, I initialize with I equals 100. Now see, we have to reduce it because 100 is less than 10. Here we got the 100 is less than 10. So now what will happen? It is false. So it won't even execute a single time. Okay. So then what we have to do is we have to give the condition according to the initialization. So you can do I equals 100, then I less than 110. So that means it's a greater value and it's a lesser value. That means at least it can be run even once time. So that means if I give I plus plus, So that means when it becomes 111, then the loop will be terminated. So that means this loop will be running up to 10 times. Okay. So now for the errors that may lead to the infinite loops that are, for example, if I greater than 0 and I initialize the value as 1, okay, then if I increment it, that means it will go 2, 3, 4 like that. So it won't meet this condition. That means it won't fail this condition. So the loop will be executed infinite times. For the same like that, if I give I equals 10, okay, if my I is greater than 20, then if I decrement the value, that means it will go in the backwards. That means 10 greater than 20. Oops, we will change the condition. For example, if I equals 10 less than 20 and I minus, that means 10 less than 20 will return true, then 9 then less than 20 will return true, and it will go in the backwards after also 0. After also 0, now what will happen? After also 0, it will go in the negatives. -1, -2, -3, -4, -5 like that it will go. So it will run infinite times because these negative values will always be lesser than 20s. So make sure to iterate through yourself so that you won't get any infinite loop stuck. And also you can add break. In the conditional statements we have seen about break that will terminate the condition. Same as here, this break will terminate the loop. Okay, then even if for running this, if you run this in your IDE, it may hang and don't actually run. So if you want to escape that, if you can't even run this, so use the task manager to kill the Java progress for the last resort. Okay, so always verify your condition will be eventually become false. So if it not becomes false, it will be run infinitely. The infinite loop wastes the CPU, and that also sometimes frustrates the users. Okay, so now we'll do some problems. For example, sum of first n natural numbers. That means 1 plus 2 plus 3 plus 4 plus 5 plus 6 like that. If we add all these, we'll be getting 21. Okay, like that sum of n numbers. N is the ending range and we'll start from 1. N is nothing but the ending range of the program. It may be 3, 5, 10. It is based upon the user. Okay, now what we'll be using is, we'll be using a for loop and we'll be declare a variable. For example, I'm naming it as sum. Okay, for example, we will be using a for loop. So before that, we'll be declaring a variable named as sum. Int sum equals 0. Okay, after that we'll declare the for loop. For int I equals 1 and I less than n I plus plus. This n is nothing but the input that is will be getting from the user. Scanner dot next int. Okay, now we will be print after the loop is break. That means after doing these many operations, we will print the output. Okay, so from this video, pause this video and code it yourself. Then after that, you will get ready to hear my solution. Okay, now let me see the solution. First we'll be code it in whiteboard. After that we'll be move on to the IDE Visual Studio Code. Okay, first I'll get input. For example, n equals, I'm taking it as 20. Then int sum equals 0, because I'll add from 1 to like that I'll be adding. After that I'll declare the for loop. The for loop will also start from 0 to I less than or equals n. Then I'll increment it by 1. Now what we have to do, we have to add this sum value with the current I value. For example, sum equals sum plus I, that's it. Okay, we'll iterate. First the n value will become 20. After that the sum value is 0, then we will come to the loop. Even if you add 0 with 0, it will give also 0, so I am just changing it to 1. Okay, then if we have to check 1 less than or equals 20, then that means it will return true. Okay, then the current sum value is 0, so we will change the sum value according to here, then it will become true. After that it will go here, then add the current sum value, sum equals 0 plus 1, that means the current sum value will become 1. Okay, then it will increment the value of I to 1. So now we have to check that 2 is less than or equals 20. That is true. So sum equals sum plus 1. The current value of sum is 1, so it will give 1 plus 2. The current sum value will be added to 3. So then again we have to check for 3 less than or equals 20. It will return true. We have to check 3 less than or equals 20. It will return true. And the value of sum will be 3 plus 3. Then that means it will return 6. Then again 4 less than or equals 20. True. Then sum equals to 6 plus 4, 10. Like that it will go until it reaches 20 less than or equals 20. Return true. This current sum value plus 20. Then 21 less than or equals 20 will return false. So after that we will get some value of the total from 1 to 20. Then we will print after that. So we have to write system dot out dot println the value sum. Okay, so now we will check in the Visual Studio Code. So I am opening the Visual Studio Code. So first we have to store it what we have adding. So I am declaring a variable. Before that I will be import the Java class. Import java dot till dot tar. After that I am creating a scanner object. After declaring the scanner I am getting input the range, that is nothing but n. So int n equals s1 dot next int. Okay, now we have to store the value that we are adding. So I am declaring a variable called int n equals int sum equals 0. After that for int I equals, it starts from 1 and its ends at n, then I plus plus. Okay, now what we have to check? Now what we have to do? We have to add sum equals sum plus I. Then we have to print the sum. Okay, now if I run this, I am giving it the range of, if I give 4 it will have to return 10. It is returning 10, so I am running it again. With the input of 5 it must return 15. Then if I give 20 we will get 2 not 10. Okay, if I give 100 I must get 50 50. Yeah, we got the output. So this code is working perfectly. Now you may think, why do we need this much line? We can simplify it. Okay, instead of sum equals sum plus I can just simply give sum plus equals I. Okay, now again I am running. See here I am giving the same input here 100. So I got the same output. Okay, we can minimize this line of code like this also. This is nothing but the assigning operator. We are doing some operation along with it. Then if you got the output as 50 50, then notice that for formula verification the good coders will always validate with the math when possible. Then next we will see the factorial. What is factorial? So we will be going from the scratch. Okay, now we will see what is a factorial. Factorial is given in the form of exclamatory symbol. If I give 1 factorial, the output is 1. If I give 0 factorial, it is 1. The 0 factorial is a special case. So the 0 factorial value is 1. Then 1 factorial is also 1. 2 factorial is 2. Then 3 factorial is 6. Now you may ask how it's working. Okay, for that 0 factorial it is always 1 and 1 factorial is 1. Okay, For the 2 factorial, it is nothing but 1 into 2 or 2 into 1. For the 3 factorial, it is 1 into 2 cross 3 or 3 cross 2 cross 1. For the 4 factorial, 1 cross 2 cross 3 cross 4 or 4 cross 3 cross 2 cross 1. Okay, we'll have to multiply this. Now you may get the idea of using the previous problems. In the previous problem, the sum of n numbers, the factorial is nothing but the product of n numbers. Okay, mostly the factorials will be used in the probability calculations and combinatorics. So we can use long instead of integer because factorials grow fast over the 20 digits. So the int will be overflowed. So we will be using long to store it. So for that, first we have to do the range. I am giving the range of 5 equals n. So after that, I am using long. For that, I am giving it as a short form of factorial. So after that, I initialize with 1. Why? Because if I multiply any value with 1, I will get the same value. For example, 1 cross 2 will return 2, 1 cross 100 will return 100. But if I use 0 instead of 1, I always get 0 because 0 times any number will always return 0. So that's why for multiplication we have to use 1 and for the summation we have to use 0. For the previous question we have solved using summation, so that's why we have used 0 with the initialization. For the factorial we have to do multiplication, so that's why we have using 1. So same goes here for int I equals 1, I less than or equals n, I plus plus, then factorial equals factorial star I. Then we just have to print sys out the value that is stored in the fact. Okay, same like the sum of n numbers. We just have to do the factorial of n numbers in the finding factorial. Factorial of n numbers is nothing but the product of n numbers. Okay, for the 5 factorial, it is 1 star, 2 star, 3 star, 4 star, 5. That means 1 times 2 will become 2, 2 times 3 will become 6, 6 times 4 will become 24, 24 times 24 times 5 will become 120. So we will get the output as 120. So now we will check in the Visual Studio Code. So then now we will run this code. We have to give some input. I am giving 5. We got the input. Okay, then next we have to run it. I am running it. Now I give the input as 5. We got 0 because see here we are starting from 0. So if you multiply any values with 0, we will get 0. So that's why I have said before we have to use 1 here. So now we will run it again. I am giving the input as 5. See, now we will getting the input as 120. Okay, so for that, if we want to know how it's work internally, now I just simply paste this within the loop. So now we will use to know how it's working. Now if I give again 5, see here, first it is 1, then the 1 will become 1 times of 2, it will become 2, then 2 times of 3 will become 6, then 6 times of 4 will become 24, then the 24 times of 5 will become 120. Okay, this is how it's internally work. If you want to know how it's working, if you just print within the for loop, then you will use to know. Okay, then this is the factorial. the product of n numbers is nothing but the factorial of a number. So then there's one more thing, that is prime numbers. For that, first we will have to know what is a prime number. Okay, then we will move on to that. First we will see what is a prime number. A prime number is a number that is divided by 1 and itself only. For example, if I take 3 can be divided by 3 and 1. If we take 4, it can be divided by 1, 2 and 4. If we take 6, it can be divided by 1, 2, 3 and 6. Okay, again if I take 7, I can divide it with 1 and 7. If I take 8, I can 1, 2, 4 and 8. Like this, if a number is divided by 1 and itself, it is called a prime number. If it gets more than 2, that means it's not a prime number. For example, 3 is a prime number and 4 is not. Why? Because it can be also divided by 2. And for 6, if I take examples, 1 and 6 and 2 can be also divided, and 3 is also can be divided the 6. So how we can say it is divided is because if this number modulus, for example 2, returns the remainder 0, it is called divided by that number. So now we have known the logic, so just we have to write the code. Okay, for that one more thing is there, 1 is not a prime number. Okay, and 0 is not a prime number. So for that, first we have to write the edge cases. These are called edge cases. If a number is less than or equal to 1 or less than or equal to 1, or I can write if a number is less than 2, I can simply say that print not a prime number. Negative numbers are also not prime numbers. Okay. After that, I have the else case. In the else case, we have to check from the to right. For int I equals 2, because we don't need to check 1. We just have to check from 2 to less than that same number. I less than the range of the number, that means the same number, then I plus plus. Okay, here because in this range of a number, for example if I take 8, we have in between 0, 1, 2, 3, 4, 5, 6, 7 and 8. Within this number, these two are always not a prime number. So we have to check from, it can be divided with 1 and itself. That means we don't need to check this condition. We have to check if it is divided by any other number in between them. For example, if I take 8, if it is, it can be, I can say it is divided by 1 and 8, and I have to check 2 to 7 if it is divided by these numbers, this 2 to 7, that means it is not a prime number, or else it is a prime number. So what I am checking here, if the number modulus I equals 0. That means it is a not prime number. So I declare a boolean value of is prime. For example, bool is prime. It's a variable name. For that I make it to declare it as true. Why? Because we are just checking it to make it to false. So if it is divided by any number, then I can change the value of is prime to false. Okay, then I just don't need to check any other number, so I am using break. If I use break here, if this passes, then this whole for block will be terminated. After this else case, I just have to print, so I am just checking if is prime. This boolean value will store true or false. If it is true, I just have to print prime number, else case not a prime number. Okay, see here, I'll explain once again. I am storing a boolean value to check it is true or false, and I have just checking in between the range of 2 to n minus 1. This is n. If I check up to this number, this is called n minus 1. So I am checking from 2 to n minus 1. If any number divided within this number, in this range of number, then that means it is not a prime number. Okay, then now we will move on to the Visual Studio Code to check this how it's work. Okay, we'll be moving. So for that I have taken an integer int n from the user, then I am declaring a variable to check boolean is prime equals true. Here why I am using true is because if I use false here, if the condition true, the condition means if it's divided by any other number, then it's also still false. So it will only return it's not a prime number. That's why we are using true instead of false. Okay, then before that we have to just use the test cases. If the n is less than or equal to 1, or else simply I can say less than 2, I just have to print it is not a prime number, else case I have to run a loop. In that what I have to do is for int I equals 2, I less than n, I plus plus. Okay, then after that, if n modulus I equals 0, then that means I can simply say it is not a prime number. So I am just giving false to the boolean value. After that I am simply breaking it. Okay, then I am using if is prime. If it is prime, I just have to print it's a prime number. else it is not a prime number. Okay, first we have to check if it is less than 2, then it's not a prime number. Then if it is not less than 2, it will be in the range of 2 to infinitive, and that means we have to check from 2 to n minus 1. That is nothing but, if you want to use n minus 1, you just have to give I less than or equals and n minus 1. This is also a correct way, but we will simply use I less than n, so it is just a simple line. So after that I have to check if it is divided by the in between range. If it is divided by the in between range, that means it is not a prime number, so I am returning it as false. So if false means it will go to the else block. If true means it will execute the same block. So now we will check. First I will tell what are the prime numbers. It is from 2, 3, 5, 7 and 11, 13 and so on. So we will check. First I am giving for 0. It's not a prime number and it's a prime. Oh. Okay. Then here we have to give this if else within this same statement. Because this if else will be executed same as well after this if else will be also executed, so that's why we have to give in between that. So we just need to give an annotation here so it will look clear. Okay, now then we can just run it. I am giving the value of 0. I got it's not a prime number. Then I just have to give 1. It's not a prime number. If I give my negative values like this, it's not a prime number. Then if I give 2, it is a prime number. The next prime number is 3, so I am giving 3. It's a prime number. If I give 4, it's not a prime number, so it should return it's not a prime number. Then if I give 5, it's a prime number. Then if I give 7, it's a prime number. So our code is working perfectly. So why I remove this line? Because if this is true, then that means it have to exit, but it will continue up to here. So that's why I have said to do this. If you don't want, or else you can use one more thing as well. For example, if I put this out of here and then if I use return statement here, then if I run it again and I give a value of 0, see, it only says it's not a prime number. But before that, see, for the first time we are running it, it said that it's not a prime number and it's a prime number. Okay, so that's why we have to use return statement here. We will see what is this return statement in the functions and methods. So you don't need to worry about this. You just need to know that we don't need this currently right now. We can simply use if else statements. Okay, after that we have done with this code. Then we will be seeing before that you may ask why I am using this is prime. It is nothing but a flag. I am using it to print the value if it is prime or not, just for my sake. So then we will be seeing the break and continue. So first we will see break. For that we'll go to the whiteboard. Then I'll teach you As I said before, if I give any conditions and after that it breaks, that means if this condition is true, if this line comes, then that means it will execute the break statement, then it will get out of this block. Okay, same like the continue, if this condition is true, it will get out of this block and continue from the next iteration. For example, I am giving if n equals 5, I just said break. One more thing, if n equals 5, I am saying continue. Okay, then that means, for example, I will take a code from print 1 to 10. Okay, in this I have written this any of one. For example, if I write this, that means if n equals 5, it should break. After that, I am printing the statement print I. That means if I run this, I will check for break and continue. In here, if I use break statement, first what will happen? I will come here and check I 1 equals 5. No, then it will print the 1. Then it will increment at 2 equals 5. False. Then it will print 3 equals 5. It will print because it's false. Then 4 equals 5. It is false. Then print 4. Then if it's come to here, 5 equals 5. Okay, then it will become true. Break. This is the output. This will entirely break that for loop. After that, if we check for continue, 1 equals 1, it's false, then it will be printed. 2 equals 5, it is false, 2 will be printed. Then 3 equals 5, false, 3 will be printed. 4 equals 5, then it's false, then 4 will be printed. Then here 5 equals 5, then continue means it will only terminate the single loop. That means it won't end the entire loop. It will just cut out of a single portion. That means then the only single iteration only skipped. Then it will move on to the next one. The value will be iterated. After that, it will become 6. 6 equals 5 false. 6 will be printed. 7 will be printed. 8, 9 until 10 will be printed. If you use break statement, it will entirely cut out the for loop. If you use continue statement, it will just give the single iteration. So we will just see that program in the Visual Studio Code. So for that, I'll remove these codes. In here, I'll just comment this line. Then I'm using int n equals 10. After that, for int I equals 1, I less than or equals 10, or else n, I plus plus. After here, we just write a condition called if n I equals 5, then that means I'm just giving it as break. After that, continue, and I just comment it. We'll see one by one. After that, I'm printing. This is how I'm just printing the I. Okay. Before that, I'll just remove this if statement as well. So we'll see the output first. So it is normally printing from 1 to 10. So I just remove this println and give some space here. So that's why it's give the output in a single line. So now see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then if I use break statement here and run it, see it stopped in the 4th iteration. When it come to this 5th iteration, it will break the entire loop. So now we will check with the continue statement. I am uncommenting it. After that I am running it. See here, it is just skipped a single iteration. When the value of I becomes 0, then a single iteration is skipped. After that, understand? Now we got two values, that 4 and 6, but we skipped the 5th value, that is 5. So break is nothing but the keyword that is used to entirely get out of the loop. But if you use continue, it will just skip a single iteration. That's why you will be using this continue and break based upon the how you can use. Then from this is the part 1. Then from coming onwards, the next videos we'll be seeing while loops. In while loops there are a lot of problems over there, so we'll be doing while loops and do while problems. So make sure to watch this entire playlist so you won't get any confused and you won't stuck anywhere. And we'll be covering what are the common mistakes that we'll be doing in this. And the main rule is that we have to write our code in a readable way. So if a junior developer can't understand your loop in 10 seconds to refactor it, the simple loops prevent bugs, complex loops creates them. So we'll be using these for loops for the non counts. The syntax is for and initialization, condition and adaptation. And the while loops, we will be using that for unknown counts. While we are seeing that in coding, you will understand why I am said it is used for unknown counts. And do while loop is same as the while loop, but it will run once. After then it will check the condition. So at least it will be run one time. And we have seen break in this video. That is the nothing but the emergency exit from any loop. Then continue is used to skip to the next iteration immediately. For this we will be covering methods and function. So we will learn how to package loop logic into result blocks, so you never rewrite the same loop twice. So functions and methods we will be seeing. So your action steps right now is to like this video and subscribe to Infosys. We drop our clean Java tutorials every Tuesday. So make sure to comment your doubts in this video, so I'll let you know how to resolve in this next videos. So I'd really appreciate if you like and subscribe this video, and make sure to subscribe and turn on the bell icon so you won't miss any of our videos. So until then, keep coding and keep growing.